Okay, I'm going to go through the calculation of a T as in Terry, score. So often we hear that the Z-score and the T-score are quite similar as far as the formula goes, but we have to do some work with the T-score before we get it to look like the formula in a Z-score. All right. And I'm going to go through this with you. I don't know how much good it's going to do. Hopefully it will help you understand it. Now again, looking at this, these are calculations that have taken place in Laurel Smith's video. So when we look at this, one of the first things that we do, and I'm going to explain this, and this is kind of a shorthand way of doing it, but I hope that you will have a grasp of the concept so you understand. The first thing that we do is look for the standard deviation, because with the, and I have to emphasize this, why we use the T-score, T as in Terry score, is because we do not know the standard deviation of the population. With the Z-score, we were aware of the standard deviation of the population. With the T-score, we are not aware of the standard deviation of the population. So what we do then is we take a sample from the population, and from this sample, we develop a standard deviation. So the standard deviation comes from the sample, and that is looking at the sum of the squares. And you recall this. This is when we find the mean, and then we subtract the mean, and then we square it to get rid of any negative sign. That's basically finding the standard deviation for a T-score. Okay, now as we go through this then, we have the T-score. This is the standard deviation. We have the sum of the squares, n minus 1. Well, in this instance, our total sample size was 16. Now remember, for a T-score, we need a sample size of 30 or less. If we have a larger sample size, the T-score begins to appear like a Z-score, and when it gets to a sample size of 100, the T-score and the Z-score are practically the same. So we have here, we have the sum of the squares, n, which is 16 minus 1. Now we go ahead and we have calculated the sum of the squares. You remember what it was like. Remember, you do not have to show your work anymore, so it won't take you nearly as long. But after we've calculated it, we have the sum of the squares at 1215. N minus 1 is 15, and we go ahead and divide 15 into 1215 and take the square root of that, and our standard deviation then is 9 for this sampling size. All right, that is the standard deviation, but we're not done yet. This is in the T-score, and we are not done. Then we take and we estimate the standard error. So this is the estimate of the standard error. Now, remember that our standard deviation was 9 over square root of n, not n1, but n, square root of that. And so we have 9 over the square root of 16, and we calculate that out, and we have the estimated standard error of 2.25. So I know this is two operations that are in there. We find the standard deviation of the sample, and then we do the T-score estimated standard error. Well, now we have the formula here for the T-score, which is a minus x, and we're going through this, minus the mean, the average for the population, over the estimated standard error. All right, so we have selected some numbers here, and what we're looking at is 35, that's our x number, that's our mean, minus 30, and that comes to 225 over here. That's the estimated standard error of the t-score. And then we subtract 35 minus 30. That gives us 5. We divide that 5 by 2.25, and we have a critical value of 2.2. A critical value of 2.2. Now this is, of course, positive. So remember this. Now what then? We have another step to follow, because you see the degrees of difference right here. And this degrees of difference is important because we go to the text, and I'm going to write the text right here, page 351. And this is where it gives us the table for the t-score. Now, going down the degrees of freedom, and we have 16 degrees of freedom. That's what we have right here. And if we go down the side, the left side of our table score until we get to 16, and then go to the right until we get to, remember, we want to have 0.05 as our alpha level. And so we go up above and we see 0.05, and we have 16, and where they intersect then is 1.74. Okay, now if we had, and I'm going to put this right up here, well, let's see here. I can do this here. If we had a one-tailed curve, and that's what they're looking at here, and the critical value, you remember we figured at 2.22. I believe that was our critical, yeah, 2.22 was our critical value. But when we look at the chart here, we're going out this way, and we have 16, we have 1.74. So this is beyond the 222. So then we would reject the null, or 80, in favor of the alternative hypothesis or the research hypothesis. The important thing to remember here that when we look up these scores, we go to the degrees of freedom. Now there are some interesting things with t-scores that I will talk to you about. We have different types of measurement with t-scores. One of the types of measurements with t-scores is an interval. In other words, it has to, in order to be valid, we'll say it has to fall between a number of, and this is just an example, of 6 and 10. Of 6 and 10. Now you compute this, 6 and 10. I don't want to confuse you. We're not going that way. We are looking at just a single t-score, and for now. However, it is not that difficult to compute it. At time and a little bit different circumstances, we would go ahead and compute them. But we are not, and when you see the formula for it, you say, hey, that's almost like falling off of a log. And so it's not that complicated. The thing that I want you to remember about the t-score is that when we go to the table, this is for right now, when we go to the table, we look for the degrees of freedom. Okay, under video 14, this covers the third part. Again, I want to put the assignments on, so if you have a desire, if you have a wish, go ahead and complete before July 1. And remember that if someone has already responded, if possible, do not have a second response. But, you know, if you have to respond the second time, that is fine. Take the shortcut. Take every possible shortcut that you can and still come up with the correct answer. You folks have been wonderful in showing your work, and I appreciate it, but I think it's time to get down to business now. Like I say, we'll be looking at T-stores and ANOVAs. Please check the videos carefully. So you folks enjoy this nice summer day, and remember, firecracker time is right around the corner.